Good afternoon and welcome to the third week of facilitations. Um, Last week, we completed discussions on functions of complex variables, and I gave us some assignments, some questions to solve. If you have any problems in solving the problem, you can ask before we move to the next things we are supposed to do for this week. So in the absence of no questions, so this week, as I said, we shall be looking at Cauchy sequence. So our main objective is to understand how to do evaluations of Cauchy sequence and solve some exercises. So before we go into Cauchy sequence, we need to understand a term called sequence in mathematics. So a sequence of complex number is a function from the set n of positive integers into C. We use the notation Zn such that n is an element, small n is an element of n, or more simply, curly bracket, set n to denote a sequence index is not unique. So what I'm trying to say is that if you have a sequence of complex number, then they are just a function from a set which are positive integer into another set. For example, now you have a building. In the building, there are rooms, 6 or 7 rooms. So the building itself now is set n. Now inside the building, the rooms now are just like the C. So if you have this, you can denote the sequence of this thing by using the term Zn such that n is what? An element of n, that is n belongs to that capital N. So an example is if Z of n is equal to small n divided by n plus I. So the question now is that shows that the modulus of Zn minus 1 is equal to 1 all over the square root of n squared plus 1. We are to use this to prove that when you look for the modulus of this, z minus 1, zn minus 1, the answer is this. So now, this is the solution. We are giving this zn to equal to n over n plus I. So I here is the imaginary. So if you now take 1 away from this, now that is z minus 1, you now have the whole of this minus 1. If you perform linear algebra on it, the denominator here is n plus ni, you have it. Then you have n minus n plus I. By the time you open the bracket, the n's will go. Then you have negative I all over n plus I. So Zn minus 1 is equal to this. If you now take the modulus of this now, so when you take the modulus is now the whole of this now, because this is Zn, take the modulus of it. So you now have I minus I minus I over n plus I, which is now giving us 1 all over n plus I. If you this one now, if you take the square of this, because the modulus here means that you take the square of each of these terms that is inside. So I squared now will give you minus 1. Minus 1 times minus to give you positive. That's why you have 1 here. So this now is just like this, taking the square of it. Then you multiply it, open the bracket, later half. By the time you do the algebra analysis, you have the square root of n plus 1. So when you come back here now and put all the information together, you now have 1 divided by n plus I, which is now the modulus of Zn minus 1 is equal to 1 over the square root of n plus 1, which is what we are asked to prove. So is that taken? So Joseph, you are welcome. Good afternoon. Can you hear me, Joseph? I'm not hearing you. So now let's move to the next thing. Now, Cauchy sequence. So a sequence is called a Cauchy sequence if the terms of the sequence eventually all became arbitrarily close to one another. That is, you said a sequence is a Cauchy sequence if the terms of the sequence, that is, they move close to one another. So an example is that given that epsilon is greater than 0, there exists n such that if m and n is greater than n, then the modulus of am minus an is less than epsilon. So properties of Cauchy sequence now. One, any Cauchy sequence is double bounded, is bounded. Any convergent sequence is a Cauchy sequence. That is, when you have a sequence that converges, then automatically it's a Cauchy sequence. So now let's look at how to prove this definition now. So that if an is tends to beta, then given that epsilon is greater than 0, choose n such that if n, small letter n, is greater than capital N, we have the modulus of an minus beta to less than epsilon. So meaning that by the time you take the difference between these corresponding terms, the result must less than epsilon. Then if m comma n, if m comma n is greater than n, we have the modulus of am minus an to equals to cam to equals to the bracket of am minus beta, which is less than or equals to am minus beta, and is equals to this. This is the proof of, because this is now convergent. So a real Cauchy sequence is convergent. That's another properties of a Cauchy sequence. Now, these are examples. In the course material I sent to you, you have some problems, most especially on page, I think that should be on page 14 or thereabouts. That is, so where you are giving some example, some problem, given that z1 plus z2 are complex variables, then z1 is si, s1 plus iy1, and z2 is x2 plus iy2. So these are the complex uh, variable now. So the question now is obtain an expression for z1 plus z2, then the conjugate of z1 plus z, the addition of z1 plus z2, and the conjugate of the multiplication of z1 by z2, and also the multiplication of z1 and z2. So the second question is that if z is not equals to 0, then it has a complex inverse z this, show that this is equals to this. If z is equals to a plus ib. So these are the problems. Now let's look at the solutions now. So the first one there, we are giving z1 and also the z2. These are the two. So we have to add them. z1 plus z2. This is x and this is s. You pick the corresponding one. So z1 is this, z2 is this. This and this are the same thing, just like lifetimes now. So z1 plus z2, you put it in bracket. Then if you look at this, this is high y1, high y2. They have something in common, which is I. You take it out. Then y1 plus y2 go in bracket. So you have technically solved this addition of two complex uh, variable now. So which give you this. Now you have to take the conjugate. What do you mean by conjugate now? This line on top of this now means conjugate. So in doing that, you just put negative inside this. So you have this, because the addition of this is this. When you put the bar on it, so this sign, positive here, you change to negative. So z1 plus z2 minus I y1 plus y2. So if you open the bracket of this now, so z1, you cannot collect those that have a kind of a sequence. So x1 and y1, they are together. So we now have x1 minus, because by the time you open the bracket here, minus I times y1, it will give you negative, so you have this. Then x2, then minus this. So the conjugate of z2 plus z1 will give you this expression. Now, let's look at the multiplication of the conjugate of z1 and z2. So this is z1, this is z2. By the time you multiply them, z x1 times this, you open the bracket, By the time you open the bracket, you have this expression. Now, you collect those one with the same sequence. X1, X1, X2, uh, Y1, Y2. They are more or less the same thing. So because I square here is -1. This we discussed this in our first class and also in the second week of facilitation. I square is equals to -1. So the whole of this now turns to negative. That's why you have y1, y2 negative here. So I commons between this and this, take it out, then you have this. Now you now apply the conjugate, put it on top of this. It is only the sign here that will change, and that's why you have this x1, x2. Then because of the conjugate now, this will change to negative. So also the last question, right? You can as well expand it and collect the lifetimes and all these things. So eventually you have this as your final result. So the last question there we are to solve for, we are giving z to equals to a plus ib. So our expectation is to find the conjugate of the complex conjugate of z, which is equals to this. So z prime. Now by the time you are trying to solve this now, you have this now. So in algebra, when you are dealing with surd, when you have something like this, you pick the denominator and find the conjugate and use it to multiply both numerator and denominator. That's what I've done here. This is the denominator. By the time you find the conjugate, it tends to negative, then you use to multiply the top and the bottom. So that's why you have a minus ib. So by the time you multiply this and you open the bracket, you have a times a squared, then b times b will give you b squared, I times I will give I squared. Because you have negative and I squared is negative, that gives you positive. So eventually, you now have a plus ib divided by this. So this divided by this minus this divided by this gives, and that is what we have asked to prove here. Say that we should show that z prime or z complex conjugate is equals to a over a squared plus b squared minus ib a squared plus b squared. So any question? If you have any question, you are free to ask me. So Joseph, you're welcome.
Thank you, sir.
Yeah, it's been a while. We started this class three weeks ago. I've not been seeing anybody coming to class. You are the first one to have come to class today. Why?
I had some challenge of technological challenge. I'm just beginning to
Okay. That's good.
resolve the issues. In fact, even using my system, I just got a phone that I'm trying to set up. Maybe by evening time, I'll complete that so that anywhere I am, I can
Okay,
access my lectures.
okay, I
Yes,
understand. Anyway,
yes.
what you just need to do is that I've uploaded the recorded videos of the last two classes, the first week
Okay,
and the second week.
okay,
So
sir.
you can follow the links. Just go to the course page and go and look at facilitation recording. You will see the recorded links. So you can click on them
Yeah,
and follow the class.
sorry, sir. I tried to click earlier today when I was able to get online. I tried
Okay.
to click to watch the previous slides. Then it didn't really open for me. I don't know why.
It didn't what?
Uh, it didn't open. It didn't.
No, it should.
Uh, okay.
Okay.
I would try it again.
It should open because the first class I've seen that about five, it has been attempted 5 times.
Okay.
Yeah. So
Oh,
let me just
oh,
show you.
okay.
So this is the video. This is the first class, and
Okay.
5 students has accessed it.
Oh, wow. Okay. All
You
right.
get me now?
Okay.
So
Yeah, yeah.
if I click on it now,
Yes.
it will take me to YouTube.
Okay. Oh, okay.
So once I click on the link,
Uh,
so this is the link I sent to you.
okay. Then I think I know why
What
the
you just need
problem.
to do is just copy the link. You don't need to click it. Just copy the link and put it in a new browser.
Okay. Now there are two things involved. My office internet has
So
restriction
this
for
is the
YouTube.
class.
Okay, wow. Okay, all right.
So
Okay,
this is the
I'm
first
actually
class.
okay. Wow. Physics 2 and 3. Okay, I can see. Mhm.
So you just need to copy it and put it in a new browser. Then you can follow the class.
Oh, okay. I think I will do that. I will do that. I will do
Okay,
that.
fine.
Yes, sir.
By the end of
Yes.
today also, I will upload the class we just finished now. So
Okay.
you can have access to all.
Okay.
Okay.
All right. Okay, sir.
Do you have
Thank you
any
very much.
question?
Um. Well, since I'm just jumping in, I think I like you. I like the detailed breakdown of the calculations that of or that you just did. I I hope you will give us some more examples for those of us
Yeah,
who are
the
just.
point there is that
Mm,
now just try to watch the video, look at the
mm,
problems and how the problem are being solved. So
mhm.
if you now have any challenge, you can contact me.
Okay.
I get you now. Ask your
Yes, sir.
questions either through WhatsApp or by email.
Okay. I've not been added to your WhatsApp group yet.
Yeah, I've not created a WhatsApp group because I've not been seeing students coming on board. You are the first person to come on board this week.
Oh my God. So
Yeah, you are
sorry
the first
about
person
that.
I'm seeing this week. So in the last two
Maybe
weeks, I've not seen any students. So that makes it difficult for me to create a WhatsApp group. I can only create a WhatsApp group when I have students on board.
so I think I guess maybe others are having the same challenge I'm having. MTN is a little bit bad. In
Yes,
fact,
internet is bad. I understood everything very well. It's very, very bad.
so I'm even happy that you're even keeping recording so that as one gets internet, you
Yes,
know, we can as well watch. But it would be good to also interact like this. In fact,
sure, sure.
is part of the resolving the problem. That's why I'm even happy. I'm very excited as we are interacting like
Yeah,
this.
yeah, that's one. That's the concept. That's the concept, and that's the idea behind all these things. So I can
Okay,
give you my phone number, which is my
okay, sir.
WhatsApp number, so which you can use to reach out to me if you have any challenge.
Okay,
So
sir.
080
All right. 080
60
60
27
27
06
06
03.
03.
So that's my
Okay.
WhatsApp number. You can also call it my personal line. That's
Okay. I'm currently flashing you right now so that you get
okay.
mine.
I will receive it. Okay. I think I got your line. 446.
Yes, sir. That's
Yeah.
my line, sir.
Okay. So go through the video. So if you have any problem, any challenge, you can send message to me on WhatsApp through that line.
Okay, sir. Yes, sir.
Okay. So thanks for
Yes, sir.
coming.
Yes, sir. Thank you very much, sir.
I used to make the video short so that it will not be too cumbersome and it will not be boring for you to watch.
Yes, that well appreciated, sir.
Okay, you're welcome.
Thank you very much, sir.
Okay. So
Yes.
I will stop the class today. If you don't have any question, just go through it, the videos. If you have
Yeah.
any challenge, then get back to me.
No, I think the lecture of today, it is clear. I
Yeah.
will still go through it since I've not joined the
Yeah,
class.
sure,
I will
sure,
go
sure.
through the previous to link up what
Once,
you are
yes,
discussing
exactly.
today.
So then you can reach out to me.
Yes, sir.
Okay,
Yes, sir.
thanks for coming.
Yes, sir. Thank you.